So in this video, we'll be starting with the project management. The project management, basically, there are two models of problems. One is activity on the arc and the second one is activity on the node. So when you look at this diagram in the picture here, follow my cursor. So this is the node, the one which is being circled 1, 2, 3, 4, 5, and 6. These are the nodes. And the line connecting these nodes is called as the arc. So activity on the arc implies the activity means the time duration required to this activity is mentioned on the arc. If you see the 5, the units may be days, units may be weeks, whatever be the units. The units, if they are mentioned on the arc, it is called as the activity on the arc. Sometimes these values that are time duration required is mentioned with the nodes itself. Then it is called as activity on the node. In this video, we are doing the activity on the arc problem. Activity on the node we will be doing in the next problem. So this is the basic problem which will be given. The arc is mentioned, the normal time, which is the time duration to finish that activity is mentioned. Then it will be asked to find the critical path. In the initial phase, we are trying to solve the critical path itself. Once we get to solve the critical path, then we'll move on to crashing and PERT analysis. So these arcs are being mentioned. The time duration has been given. Units depends upon the question. Those we converted into this diagram. We have already drawn the diagram. So this is just a basic diagram where the nodes have been connected using the arcs and the respective weight has been given. You see, randomly pick up 3, 4. So 3, 4, if you see in the diagram, node 3 and node 4 are connected. The weight is 6.83 and the weight 6.83 has been mentioned here. Similarly, you can just connect the nodes and just write the weight. So after that is done, we are trying to calculate the critical path. So what is a critical path? It is nothing but the longest path required to move from starting node to the finishing node. That you can do it manually also. You can just write 1, 2, 6, 1, 2, 4, 6, 1, 2, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 3, 4, 5, 6, 1, 3, 5, 6. All the paths you can write them manually and then calculate the total cost required or total units or time taken to finish the entire project. But here we are doing it using free float method. So what is a free float method is we calculate the forward cost and the backward cost of the entire project, and depending on that we get the critical path. So the ultimate critical path is 1, 2, 3, 4, 5, 6. How did we reach here? You see, just follow my cursor for this. 1, 2, 3, 4, 5, 6 is where I am pointing out. That is the ultimate critical path. It is the longest path of this entire activity. Why are we taking the longest path is for activities to be finished, they are given certain timeline. Within the timeline, if you don't finish the activity, you'll be charging a penalty. In order to avoid that penalty, we are checking those points or those activities which are taking maximum time to finish. And we are trying to efficiently use the resources. So the longest duration of time taken by the activities is reduced. So we don't have to face the penalty charges. That is why we are looking at the longest path. Why is it called critical path? Critical to ensure the deadline is met. So no additional cost, which is penalty, is levied on us. Then how to calculate the forward and the backward cost. Forward cost, by the name itself, it says you have to move from starting node, which is the node number 1 in this case, to the finishing node, which is node number 6. So when we are moving from these nodes 1 to 6, we follow all the arcs. So how we follow the arcs, we can just, if you see in this photo, you see the nodes are being mentioned. Each node, the outgoing nodes give us the cost. For the first node, the cost is 0 because to reach node 1, you don't have to do any other activity. So the initial cost is 0, just one value. So that 0 is the forward cost. For node 2, see how many incoming nodes are there. When we are going forward, we see the incoming nodes. When we are moving backward, we see the outgoing nodes for the backward cost. So for the forward cost, for node 2, how many incoming nodes are there? Only one. The cost is 5. Since there is only one, that becomes your forward cost. Next, we come to node 3. How many incoming nodes are there? Two nodes are there. 1, 3 and 1, 2, 3. Two arcs are there, sorry, two arcs, 1, 3 and 1, 2, 3. So 1, 3, the cost is 4. We have written 4. If you are coming through 1, 2, 3, the cost is 5 plus 0. So 5. 5 and 4. For forward, we take the highest cost. You're having more than one cost, you take the highest cost. So 5 becomes the forward cost. Then for the next node number 4, how many incoming nodes are there? This is one incoming arcs are there. This is one incoming arc. This is one more incoming arc. So two arcs are there. One arc is coming from 2, one arc is coming from 3. You need not always backtrack the entire thing. Since this arc 2, 4 is coming from 2, what is 2's forward cost? 5. So 5 plus 4 is 9. So 9 becomes your cost when you're coming through this path, 2, 4. When you're coming from 3, 4, 3's forward cost is 5. So 5 plus arc cost, which is 6.83. 5 plus 6.83 is 11.83. So out of these two, highest becomes 11.8. That becomes the forward cost for node 4. Then for node 5, there are two incoming arcs. These are 3, 5 and 4, 5. So for 3, the highest forward cost is 5. 5 plus 4 is 9. It becomes one entry. For 4, the forward cost is 11.83 plus arc cost is 5, becomes 16.83. That is becomes 16.83 is maximum. So it becomes your forward cost. Then for 6, there are 3 incoming nodes. That's why you see 3 entries here. From 4, 4, 6, 5, 6, 2, 6. So for the 2, the forward cost is 5. 5 plus 7.5 is 12.5. Then for 4, the forward cost is 11.83 plus 6.3, which becomes 18.13, which is here. Then from 5 to 6, for 5, it is 16.83 is the forward cost plus arc cost is for 20.83. So this 20.83 is the critical path length. You got the length of the critical path and through the forward cost have been calculated. Now we start from the backward cost. For backward cost, we move from finish to the end. So for the backward cost, we see the outgoing nodes. How many outgoing nodes are there for the particular node? For 6, there is no outgoing node. The maximum cost, which is the critical cost, is 20.83. So that becomes your backward cost. There is only one cost, 20.83. That is your backward cost. For node 5, see how many outgoing nodes are there? Only one is there. That is going to 6. In forward, we have added the cost. In backward, we will subtract the cost. For 6, the backward cost is 20.83 minus the arc cost is 4. So 16.83. Since there is only one outgoing node, that becomes your backward cost. Now for node 4, how many outgoing are there? 2 are there, 4, 5 and 4, 6. So from 6, it is 20.83 minus 6.3, which is 14.53. Then from 5, 5's backward cost is 16.83 minus 5 become 11.83. Now, if two values come here in the forward, we have taken the maximum value. In backward, we take the minimum value, which is 11.83. Similarly, if we just move the backward in the same sense for the same arcs, we'll get the respective number of costs and that we'll set the backward cost. The in forward, you'll get those many values here as many number of incoming arcs. For backward, you will be getting as many outgoing arcs. For forward, you sum the values. For backward, you subtract the values. Forward, you take the maximum of the cost. Backward, you take the minimum of the cost. Then this critical path is that path which gives you the longest path. Means the longest duration to finish the entire project is your critical path. So this is using the free float method. Both forward and backward costs are calculated in the respective way. And we have found the critical part to be 1, 2, 3, 4, 5, 6. 1 to 2 is 5, 2 to 3, 0, 5 plus 0, 5, 3 to 4, 5 plus 6.83, 11.83. Then 4 to 5, 11.83 plus 5, 16.83. Then 5 to 6, 16.83 plus 4, 20.83. That is your longest path for the project. That is the critical path. In the next video, we'll see the activity on the node and also the PERT analysis.